going to talk about something called total internal reflection. So suppose I've got this situation. I have a boundary between glass and air. So I have a ray of light inside this glass. You can imagine it's like a window pane or something like that. And when it comes out and hits the boundary with the air, it bends. Light always bends when it's at a boundary between two different media. And when it goes from glass into air, it bends so the angle is bigger. So this angle is bigger than this angle. But the biggest this angle can be is 90 degrees. And so I reach a point where if the angle inside the glass is big enough, it can't come out. There's no way. I mean, it should be an angle bigger than 90 degrees, but it can't. So in fact, what the glass will do, the glass surface will reflect the light back. And this is a phenomenon known as total internal reflection. It doesn't make it through. This is called refraction. It reflects. This is called reflection. Now we're going to take a look at a light bulb. And a light bulb has got air on the outside, and then it's got glass, and it's also got gas on the inside. So there's three different media, two boundaries. And under normal circumstances, what happens is this. Light that goes from the outside of the light bulb into the inside goes from air into glass and then to gas inside the bulb. Okay? So this is outside the light bulb. This is the actual glass envelope. Here's inside the bulb. And normally what happens is this. The light goes from the air into the glass, and it bends to a smaller angle. Then it goes back into the gas inside the bulb. It bends away. Net result, the ray of light ends up being displaced slightly to the side, but the angle in the air is the same as the angle in the gas. But if I took the light bulb and dunked it into water, here's what would happen. I've got water here, I've got glass here, and I've got gas inside the bulb. Then what happens is this. Ray of light comes in, and it bends, but the water is near to the density of glass, and so it doesn't bend as much as it would. And as a consequence, when it hits this surface, I might meet the condition for total internal reflection. And so the ray of light bounces backwards, and so the light won't get inside the bulb. It'll bounce back, and so I'm going to have what looks like a mirror reflection at this surface. I can have the conditions for total internal reflection. And here's what it looks like. So we have here a large light bulb, and it turns out it doesn't matter the type of light bulb that you use. Frosting has to be on the inside. There's frosting on the inside of the glass envelope. It's a big light bulb, and we put it inside this socket, and we've wrapped this with electrical tape to keep water from getting inside here. I'm going to take this fish tank filled with water, and I'm going to dunk the light bulb in it. And when I do that, you can see that I have this silvery look. Well, that silvery look is the reflection. It's the total internal reflection from the inside surface, as we talked about. And so I have a very, very different look for the light bulb. Now, once the light bulb's actually inside here, I'm taking care not to put the working part of the bulb into the water. The bulb is wet. The socket is dry. I can actually take this socket and I can turn it on. And if I do that, my light bulb lights, and then I get an even better effect here. Now, the only difficulty which you might run into if you were to try this with the light bulb on is this. If I have the light bulb out in the air and I turn it on, it gets very, very hot. Hot glass in water, you can have the glass crack. But if it's already submerged and you turn it on, the filaments and all the electrical parts are separated from the water by a layer of glass, and so everything's fine. This is safe, and it just looks awesome. And you can see the change in the size of that glowing globe of light from the frosted layer inside the bulb. And the wonderful reflections, and I can see reflections of things around the room inside this apparently mirrored surface here, which is the total internal reflection that I'm seeing. So I get a distortion, and I get mirror reflections, and it's all due to the fact that I've changed the medium on the outside of the bulb, water, glass to gas, instead of air to glass to gas.